Let's try to solve problem number 9 here. Okay. So we are given that U and V are non-zero vectors. We would like to know under what condition that the magnitude of the vector addition equals the magnitude of, or the magnitude of U plus V equals the magnitude of U minus V. Okay, so let's see. I have derived this ahead of time so that to save time during the video. Okay, so we are given that V does not equal 0 and U does not equal 0, and we want to know under what condition is this going to hold true. Okay, so let us say, without loss of generality, that U is a two-dimensional vector, Ux and Uy. If we add the Z dimension, we will just complicate the problem and reach to the same conclusion. But just for the sake of this illustration, I'm going to assume that U and V are two-dimensional vectors. So it's Ux. So my U has two components, Ux and Uy, and this is a transpose symbol. Okay, it means that this is a column vector, not a row vector. Okay, transpose means that this is Ux, Uy. Okay, all right. So and V the same. Let's suppose that V is Vx and Vy. Okay, so U plus V is nothing but has the two components Ux plus Vx and Uy plus Vy. All right. If you want to find its magnitude, it is this. And similarly, the magnitude of U minus V is similar here. And so we would like to know to solve for the problem in which these two, what is the condition that these two quantities are equal. Okay, so what is the condition? It means that you need to solve the equation basically. Okay, so this equals this, or this equals this means that this equals this. So you square both sides, you reach to this equation. Okay, and then expand these squares. Okay, to get this horrible looking equation. Okay, but it will simplify to a very simple equation. Because why? Because Ux square will cancel with Ux square on the left and right hand side. Vx with Vx squared. Okay, Uy squared with Uy squared, and Vy squared with Vy squared. So you are left with these quantities, 2Ux Vx, and here this is in the left hand side, and then the right hand side we have minus Ux 2Ux Vx. So in general, if we transfer it to, or put it in one side, we get 4 Ux Vx, and similarly we get 4 Uy Vy, and this equals 0. If you divide by 4, you get what? You get Vx or Ux Vx plus Uy Vy equals 0. What is this? This is the definition of the dot product. Okay, dot product. Okay, so this thing here is nothing but the dot product of U and V, and this equals 0. So this is the condition here. What does it mean? It means that U and V are perpendicular to each other because their dot product is 0. And if you remember, the dot product is also related to the cosine of the angle between the two vectors. So V, magnitude of V and magnitude of U multiplied by the cosine of theta. And when does the cosine get 0? It's when the angle is 90 degrees, or when the two vectors are perpendicular to each other. Hope you enjoy it. If you have any question, you can come back and discuss this with me. Otherwise, see you next week.